Do you know that this industry consumes roughly 1/3 of the global energy consumption? 75% of this energy is used for heat production. And over 90% of the heat is still produced by fossil fuels in industry. I'm Fabian, CEO of Ecop. Ecop is an inventor and manufacturer of the rotation heat pump. We offer the replacement of gas for production of industrial heat up to 200 degrees at the fastest ROI. The principle is simple. We use temperature-based heat at a temperature level that is not suitable for processes anymore, and lift it with the use of electricity to a temperature level that can be used again for processes in the industry. How we do that? The rotation heat pump uses a different thermodynamic cycle process than conventional heat pumps. It uses a completely climate-friendly, non-toxic, non-flammable working medium that is compressed and expanded via rotational forces within a rotator that is running inside the machine that you can see on the upper left here. This principle has mainly two advantages. First, the efficiency is higher than the compression in a conventional turbo compressor that runs at way higher speeds, leading to a magnitude of higher losses than the compression in our rotation system. Second, we do not have a phase shift in the system. So we are not limited by the physics of the phase shift of the working medium. So we can use the entire temperature envelope from -50 to 200 degrees C with the same application and the same heat pump. The main USPs that comes from these advantages are we can realize very high temperatures up to 200 degrees C at lifts of up to 100 degrees. That is outstanding. Conventional heat pumps come to maybe 60, 65 degrees. If they want to produce temperature or heat at 200 degrees C, they need a second step, either a second heat pump or a mechanical vapor recompression or a, let's say, electric boiler. Second, we have, due to the high efficiency, we can realize COPs of 3 to 4, even at lifts of over 70 K. That brings us to better prices in comparison to gas, even in many applications. The eco-friendliness and the non-toxic and not flammable I already mentioned. And last but not least, the flexibility of the machine is super important. So we can use waste heats at different temperature levels and can produce heat at different temperature level as required. Just a reminder, 1 point in COP yields to over 100 K of energy savings, of energy cost savings. This is how the new machine, the latest version of our machine looks like. We are super proud. I do not want to go into the details, but the new rotor design is made by a technology that is called diffusion bonding. That gives us a possibility, A, to reach these outstanding spec, and B, to really scale up production because we have realized the entire rotor where the physics runs in just one block that is supplied by a supplier. 2 of these machines are already sold to our first launching customers. Third and fourth that will produce next year are close to be sold to the next launching customers. Here's a nice use case that we developed with a brewery, with a large brewery from the Netherlands. You can see that on the source side, the brewery wants to cool down certain things, and we use the heat from the cooling system to lift it to 160 degrees that is required for the brewery process. And this, at a COP of nearly 4, yields to a return on invest of lower than 4 years, with savings of 1,700 tons of CO2 annually and over 170 K in cost for gas. Industry heat pumps are set to take off. This is a result of a recent study by McKinsey predicting a 40% year-over-year growth of the industry heat pump market until 2030, and this is exactly what we're noticing. With the new rotor design, we can really scale this application, but this is, of course, something that will come, that we will see in the next years. We can go to higher power, but also to lower power. We have ambitious targets. We first will set up a production in Austria, realizing the first pre-series machine next year, and starting with a series production of 13 units in 26. And then, of course, I'm a former investor, as Jan mentioned. We are planning to go for a gigafactory in parallel from 2028 onwards. We have now looking for a CLA round that is that we will realize most likely with a strategic investor, and go for a larger round next year to set up the production. We have a strong team that need to be more diverse and more equipped with further people that will be hired well in the course of the next 2 years. And I'm happy to work with everyone, talk to all of you, and yeah. That's it. Let's do the heat transition industry together. Thank you.